It has been over 110 years since China's first hydropower station, Shilongba Hydropower Station, was built in 1910. With the support of advanced dam construction technology, the Chinese installed capacity keep rising in rapid growth, hitting around 356 gigawatts nationwide by the end of the 2019, and the annual electricity production exceeds 10,000 terawatts. At the present, China contributes to 25% of the global installed hydropower capacity, ranking first in the world for 20 consecutive years since 2001, and surpassing the combine of the four countries ranking the second to fifth. This paper reviewed China's progress in the context of the global hydropower development and examines the role of the technological advancement in supporting China's hydropower projects, especially dam construction technology. China is currently actively promoting the integration of wind, solar, hydro, and coal power generation and energy storage, and building a smart grid of multi-energy complementary power generation. New technologies and new concepts are expected to continue to lead the world's hydropower development trends. Dam is the principal structure for the hydropower generation, so the number of dams speaks for the activity level of the hydropower development in a country. A large dam is defined by the International Commission on Large Dams as any dam above 15 meters in height, or any dam between 10 meters and 15 meters in height impounding more than 3 million cubic meters. According to this definition, there were 58,713 large dams worldwide in 2020. China has 23,841 large dams, the most among all countries, and more than a combine of the following: United States 9,263, India 4,407, and Japan 3,130. It ranks the world's first with a share of more than 40%. In fact, in addition to the storing water to power generation, dams can handle natural runoff through this reservoir regulation to render functions such as a water supply from upstream reservoirs, downstream navigation, and river ecological flow maintenance. This helps alleviate the plague associated with the flood, drought, electricity shortage, and water environmental degradation. In particular, hydropower development avoids greenhouse gas emissions of thermal power generation. In view of this, the United States has incorporated hydropower in many targets of the 17 Sustainable Development Goals published in September 2015. More than 100 countries have so far made it clear that they will continue to build dams and develop hydropower. It is estimated that by 2035, global installed hydropower capacity will add by about 480 gigawatts to reach 1,750 gigawatts, with annual electricity generation of 6,100 terawatts and hydropower exploitation rate of 38.6%. And by 2050, global installed hydropower capacity will further grow by 300 gigawatts to reach 2,050 gigawatts. China has set an example for the global hydropower development. At the end of the 2019, China's installed hydropower capacity hit 356 gigawatt, with an electricity output of 1,300 terawatt, accounting for 27.2% and 30.8% of the global total respectively. Such as a scale is more than 3 times the United States, and larger than the combine of countries ranking second to fifth. China has grown into veritable hydroelectricity powerhouse based on many super large dams and reservoirs. Next, China's course and achievement in hydropower development will be reviewed, and potential challenges to China's suitable hydropower development will be analyzed. Concrete gravity dams with a simple structure and a clear stress can integrate various spillway combinations to ensure high reliable resistance to flood hazards. They are well adapted to terrain and geological conditions by arranging flexibly various types of the power plants. In the early 1930s, the 221-meter Hoover Dam was built on the Colorado River in the United States, marking the arrival of the rapid development period of the dam constructions. In the 1980s, group of the ultra-high gravity dams, embodying the dam construction technology of the 20th century, was commissioned to play an important role in the river flow regulations, flood control, power generation, irrigation, and water supply. The 285-meter high Grand-Dixon's Dam, built in Switzerland in the early 1960s, remains the world's tallest concrete gravity dam. In fact, humans have harnessed water for thousands of years. Due to the late invention of electrical technology, it was not until 1878 that the world's first hydropower station was constructed in France. In the next 100 years, hydropower gradually became the second largest source of the power generation, after thermal power by virtue of the low operating cost, simple electromechanical equipment, and operational flexibility. Super hydropower stations born after 1990s are all from China, in contrast to foreign ones built before 1990s. In particular, 11 of the world's top 20 super hydropower stations and 4 of the world's top 5 hydropower stations are located in China. The Grand Coulee hydropower station from the United States, the oldest in the ranking, was commissioned in 1942 with an initial installed capacity of 1.97 gigawatt, the largest at that time. It was expanded in 1967 and completed in the 1980s. China's Jinshu River, originating from the Qinghai-Tibet Plateau, rendered the strongest power generation capacity, secured by 4 super hydropower stations. This is attributed to large high difference, water abundance, and perfect terrain, with towering mountains on both sides. The Baihetan Dam has 6 floodgate structures and 3 spillway tunnels. The flood discharge capacity of the project is 42.346 cubic meters per second. China Three Gorges is responsible for the construction of the Baihetan hydropower project. CTG collaborated with the Dongfang Electric Machinery, a power generation equipment supplier based in China, to develop the first 1000 megawatt turbine generator for the project. HBIS Wustil was constructed to supply the turbine stay rings, generator lid and control rings. Dongfang will supply 8 turbine generator units to be installed in the left bank powerhouse of the Baihetan project, while Harbin Electric Machinery Factory was constructed to supply the remaining 8 units of the ring bank powerhouse. Caterpillar supplied machinery used in the earthworks of the Baihetan hydropower project.